We are team number 4 and we are composed by Andrea Cobian, Andrea Patiño, Linda Meneses and Mariana Soto. And this is practice number 4.
The objective of this practice is to know the operation and the use of the impact pendulum, to realize normalized essays of Sharpie impact at different temperatures and interpret the results.
Hello, my name is Linda and I will talk about the procedure that we did in the lab. First, we took the measurements of the pieces. We took the length, the width, and the height, and the location of the group. Second, we raised the mass of the Sharpie pendulum till it formed an ankle. Then, we keep the pieces in the freezer until the selected temperature is reached, and then we located the selected Sharpie specimens in the probe holder, and then we release the mass of the pendulum that will produce the fracture of the specimen, and then we took the measurements of the energy consumed during the impact. Also, we determine the morphology of the fracture. So we decided if it was a brittle or a ductile fracture. And we also checked the separation of the sample after the fracture. So if there was a fracture, yes or no, and that's all we did. Question number 4. Steel is an iron alloy with a small proportion of carbon. The more carbon we have, the impact resistance decrease. As in steel, we have more iron than carbon, the resistance to impact is greater. Question number 5. If we have more carbon, it is much easier to break. If we have less carbon, it is less easy to break. And if the temperature is bigger, the energy we use to break it is bigger. And if the temperature is lower, we need less energy to break the material. That's why the form of the fracture is ductile, because as we have less carbon, it is much difficult to break the material, and we have a normal temperature that makes also difficult to break the material, and that's why we have a ductile fracture. Our results compared with the literature were very similar because we obtained the same kind of fracture that
Impact
was
resistance.
ductile.
It is called the resistance of a member or assembly to dynamic loading. Also refers specifically to an insulation's ability to withstand damage or abuse to a piece. Sharpie impact testing involves striking a standard notch specimen with a control weight pendulum that is swung from a set height. Sharpie tests show whether a metal can be classified as being either brittle or ductile. ISO test it is a test of a metal's or plastic resistance to impact that is made by determining the amount of energy in foot-pounds needed by a swinging hammer to fracture a notch test piece of the material held in a vertical position and supported at its lower end.
A ductile fracture occurs after a material has been subjected to excessive plastic deformation. This fracture has the following characteristics: necking, material elongation, permanent plastic deformation, and reduction of cross-sectional area. Fragile fracture is the one that occurs before or during the moment in which a plastic deformation happens. The fragile fracture can be defined in two steps: onset of intragranular fracture and fracture propagation. It is mainly present in non-crystalline materials at very low temperatures and in the application of very high stresses.
The transition temperature is that at which the properties of certain materials begin to change, typically from very fragile behavior when the temperature drops to very ductile behavior when the temperature rises. While we still exhibits this behavior, copper and aluminum do not. Some of the applications for the impact test are in the forging industry. For example, the Sharpie test can be used to determine the malleability and ductility of a material that is being forged. In the rubber industry, the test can be used for determining the shock absorbing ability of a type of rubber so that its proper application could be decided. And in the plastic industry, the test is used for analyzing the breaking strength of a sample when it's subjected to a high impact from a pendulum.
During this practice, I learned to be careful in the usage of the machine because the pendulum was really heavy, and when it came back, we have to be ready to take it and place it back to the origin.
To conclude, I learned that certain materials can change their properties depending on the temperature because the temperature makes them more ductile or more elastic, and it's essential to know that if we want to know how to apply that material in the industry.
My conclusion for this practice is that the pieces with a normal temperature had a greater energy absorbed, and the pieces with a temperature of minus 16 degrees had a smaller energy absorbed.
What I learned in this practice is that we have to give the necessary importance to the mechanical test, in this case impact test, because they allowed us to know the properties and applications of the materials.